discussion is on calculation of the capacity of transformer required for specific purpose. Specific purpose means it may be a requirement for a residential complex, or it may be required for commercial complex, or it may be required for industrial complex. So before calculating the capacity of the transformer, the capacity of the transformer is calculated in kVA. The rating of the transformer is in kVA. So when we have to consider the before calculating these things, we have to consider the factors. That is, what is the total connected load, and what is the your type of load, and what is the future expansion, and what is the operating conditions. To find out the connected load, we have to add up all the loads in kilowatt. What are the equipments, the drawing load, division of equipments, maybe light or fan, or maybe AC or small motors for residential complex, or maybe for commercial complex also. So before, first I have to calculate the connected load. When after calculating the connected load, you have to divide it by power factor. By dividing the power factor, the capacity will become in kVA. So what is the rating of the transformer required in kVA? If the loads are given in HP, then finding out the total HP, we have to multiply a factor 0.746 to find out the total connected load in kilowatt. So in a residential or commercial complex, or in industrial complex, industrial load, in case of industrial load, the power factor is 0.8. And for commercial or residential complex load, we take 0.9. In residential and commercial or industrial load, we are generally use the loads as fans, AC, or small motors, and we are usually do not run at all the loads usually don't run at the same time. So we have to take some diversity factor, that is 80%. Hence the load on the transformer is calculated as the 80% of the connected load. So for residential commercial load, we have to take the diversity factor as 80%. Similarly, for industrial loads, in industrial loads generally the loads are motors, holding compressors, in addition to other loads. The loads draw high starting current, and here the diversity factor is taken as 120 to 150% of the connected load. Hence the load on the transformer is taken as 120 to 150% of the connected load. Then another thing is your demand factor. What is demand factor? So all the connected load are not run at the same time simultaneously. So we take the demand factor, a term demand factor, and it is taken as 60 to 70% for residential load, 70 to 80% for commercial load, and for 80 to 90% for industrial load. After that, we have to take the margin, adding margin for future expansion. So some extra capacity is added for future expansion. So next we may require the higher voltage class transformer also. May take suppose we may require 11 by 433 or 33 by 433 or 33 by 11. Actually here the voltage class, higher voltage or lower voltage, anything else, we need not require. The total kVA is not hampered or it is not disturbed. 20 kVA irrespective of the voltage level. Only here changes the insulation class. Uh, Insulation class means that design factor. The insulation taken in the transformer is as per the voltage level. For explaining better, we can take specific examples. For suppose for residential area, the total connected load, suppose a residential area is 300 kilowatt and power factor is 0.9 and your demand factor if I taken 0.7 means 70% is 90%. So effective load here 300 into 0.7 demand factor, this becomes out to 210 kilowatt. The transformer kVA, to find out the transformer kVA, we have divided by this 210 kilowatt divided by power factor 0.9. This will come out to be 233 kVA. So adding spare 30% extra capacity for future expansion, it will come out 233 into 1.3. This becomes 300 kVA. So nearest standard rating transformer available in the market, that is 315 kVA. Similarly, for say small factory, suppose a connected load, we have calculated connected load is 150 kilowatt. Here the power factor we take 0.8 and demand factor you have take here 0.85. The effective load will be 150 into demand factor 0.85. This becomes 128 kVA. And to find out the total kVA of the transformer, we divided by 128. Suppose this is it is the 128 kilowatt. This is kilowatt. This is kilowatt. So the transformer in kVA, that is 120 divided by 0.8, that is 160 kVA. So transformer required is 160 kVA, but nearest 160 kVA standard transformer is not available in the market. There is some specific standard transformers are available in the market. We have to purchase the nearest available rating of the transformer, which is 200 kVA. We have to purchase 200 kVA transformer for this small factory. So these are the simple idea or simple concept to calculate the rating of a transformer. How much will be the budget towards our procuring the transformer? Today's discussion this much. Thank you.